Welcome to today's talk about the Webster CyberLab. Today we're going to talk about the access mechanisms, and I'm Fred Cohen, the director of the CyberLab. Here's the outline. We'll move right on through it. Why this video? Webster provides a global research and education facility. Having more than 100 campuses worldwide, it's necessary for us to not have 100 copies of the CyberLab everywhere we're going to teach the courses. So instead, we have a centralized but redundant facility. So we have multiple locations around the world where we provide a distributed capability to support the CyberLab efforts. The key properties we're trying to achieve are integrity, availability, confidentiality, use control, accountability, transparency, and custody. But for the CyberLab access layer in particular, we're always trying to support scientifically valid experiments. In addition, we want safe, efficient, and global authorized access, as we're trying to facilitate people getting in without creating a situation where people that aren't supposed to be there get there. Access layers here support availability and use control. And in particular, the availability requirements are access, fault, intolerance, and redundancy, and the aspects of use control are identity, authenticity, and authorization. We do this by transparency is one of the objectives of our overall protection program. So it's necessary that we be transparent about how we do what we do. And so that's the reason we're showing you the slide that describes how it is we do this. Basically, access follows the process. You follow the process, you get access. It's fault intolerant in that the process minimizes our efforts and our errors in granting that access and supporting it. Redundancy is provided by facilities. So they're redundant facilities and enough capacity to support the effort. We hope that this helps, but of course there's never enough for everything that could ever go wrong, so sometimes things do. Users are given an identity of some sort, some information for their classes. Authenticity is supported by the access control mechanisms, and authorization is produced by the access control layer. Just to be clear about transparency, this process and mechanism that we're going to describe was developed in 2014. It's developed using Linux systems running scripts of various sorts, and these slides describe that process. Basically, we have a reservation system. Access is granted based on a reservation. The thing about reservations is you make them in advance, and we don't have a way to mediate who's allowed to reserve what when, other than the first person to make a reservation for an available slot in an activity gets it. So you might be tempted to immediately reserve the best times, one right after another, for yourself so you can get the lab done or something like that. And you should be careful about how you do that. There are a finite total number of slots and activities. An activity is typically a lab exercise, but it might be some other activity. It's a predefined something you're going to do requiring use of some set of resources. Usually it involves a specific configuration of particular mechanisms. So it might involve setting up a particular website or an SSL server or a chat session or a virtual machine or a network or what have you. A slot is a period of time of usage of a facility. So usually, the configuration of the facility is reset at the start of the time slot, and then the resource exists for a period of time, which is that time slot. And at the end of the time slot, the automation resets it for the next use of whatever those facilities are. So at the end of the time, whatever you're doing will just stop, and you won't have any choice. The automated mechanism will cause it to stop. So you need to watch your time and understand, what the rules are, or you're going to get hurt in the process. An example is the distributed denial of service lab. Usually a user will get 3 one-hour time slots over a 2-week period. So in that sort of circumstance, you need to remember some things about your reservation. One of them is it's physical. Right? There's no magic here. There are finite time frames and finite resources. The total resources available are adequate, but not excessive. So you need to plan ahead. And cyber doesn't mean magical. There are real things here. The resources might fail. We have some extras, but not a lot of extras. So you need to plan in advance in case the resource doesn't work at that time. You have to have another time slot planned where you can do that part of the process. Also, don't wait to the last minute. There may be no time slots available near the end because other people might have waited for the last minute, or because some people might have pre-reserved things near the end just in case they didn't get it done in the first couple of attempts. And we won't free more of them for you. And the reason is the allocation process happens once at the beginning, and that consumes all the available resources. So there aren't any spares. If you don't use a slot early on, it goes away. We can't go back in time and reallocate something that is in the past. Also, it's advisable not to use all your time slots at the same time. That is, not to schedule everything for the first available, 3 2-hour sequences in a row. The reason is if you don't finish in one time slot, you might want some time to think it over before your next attempt at the lab. So it's useful to have the time in between time slots. And you want to be careful not to waste your time when you're in one of these time slots because you only get so many of them. So you want to typically plan an early slot to learn how the environment works. Certainly, as soon as you can, you should try and schedule a time slot, and then reserve slots over the assignment time frame to make sure that as you progress through the assignment, you'll have another shot later, and you won't be competing at the last minute for non-existent resources. How do you access it? Well, let's walk through it. What you get is typically a URL to go to in order to get started. Here's an example of a URL that's and we'll go to that URL in a minute just to show you. But first, I'm going to take you to an actual URL. That one in the particular one isn't an example. And this is what our test reservation system looks like. This isn't the actual reservation system. It's just one we tossed up there for the heck of it, so we could show you how it works. What I'm going to do is I'm going to go to this other URL. Note that we're using tinyURL for this example. We won't always be using tinyURL. We might use a Google URL or who knows what. And the key to understanding here is there are a very large number of possible URLs, and they might point to this, or they might point to something else. There you go. You don't know what they'll point to. So if you don't have a valid URL to go to, you're going to go somewhere. We just don't know where. If you have a valid one, you'll get into some reservation system. And like I said, we don't know what it'll look like in advance because we make them up over time. When you go there, you get redirected to the reservation system, to that tiny URL. If you get it wrong, we'll go, we don't know where. So if you try to guess, you'll be doing guesses for a while to try and find a legitimate place to make a reservation. And the locations of reservations change over time, so be warned. You'll get a unique identifier. It's just for you. Each student has their own identifier, and it'll include various things. In this particular case, and they don't all necessarily look like this or have to look like this. We can pick one of these menu items and put in some 2 pieces of information. We're going to assume the first one always is the unique user ID. We'll say Joe. And the next one is the activity code. We're going to say lab 1, and we'll hit go. And it tells you the answer. The thing is, this isn't the actual answer. This is a deception. So if you type in any of these things incorrectly, you'll get led to the wrong information. In this case, it tells you to use this command to, and you log in as root with this password over here. And in fact, if we do it again, we'll get a different place to go and a different authentication code and maybe a different time slot. So you can understand the challenge here. We don't want you to put in wrong data, but if somebody puts in wrong data, we're not going to say, oh, that's wrong data. We're going to give them an answer that leads them down a path wherever it is. So if you get it wrong, you'll go, we don't know where. And everything is case sensitive. So the best thing to do is copy and paste. Typically, there will be things, like, skibberblub or something like that, or not, and some complicated sequence. And these are generated pseudo randomly for the test today. When we're going to show you how this works, we made something up that was sufficiently simple so I could actually remember it instead of having to copy it. So I'm just going to say FC, and it's going to say test. And so this is a potentially authorized. And what it does is it tells you reservation options. Now, typically for a lab, you'll have a lot of reservation options, right? You might have 100 or 1,000 of them for all the time slots for a lab or a set of labs over a course. And but by the time you get to the end, there will be none left. So we're going to pick one. We'll just pick the one in the middle here, and we'll say go. And what it does, it says, here's how you do it. You go here at that date and at that time. So we're just going to go there now. That's just a website I've put up. But whatever it tells you to do, you follow those directions. Now, since it's supposed to happen at a later time, in this case it was yesterday, since it's supposed to happen at a later time, if you go there at the wrong time, you might get who knows what. So if you don't go there at the right time, it won't work. So somebody getting old access information or something like that will end up just going to deception, not actually doing the activities of the class. And then finally, I want to note that because of the particulars of how complicated this might be, normally you would want to save whatever you're doing as a slot or date or time, some file, so that you have a copy of it. So when the time comes, and you should put the time in your calendar, whenever the time comes, you'll have the information you need to access it, because there are no second chances. You won't get this again. This is it. Somebody trying to get it later, you'll see what happens if they could try. But as an example, you see the URL here. I could simply do a reload, which I'm going to do now. And what you'll find sorry, your reservation failed to properly schedule. It's already been scheduled in that last one, so you lose. If you go back, you get to the reservation options. And we'll just note that the reservation options, there are only 2 left because that previous time slot was consumed. I also want to note there's a reference date and time. In this case, it says it's 6:23 and 29 seconds. And the actual time that I have according to my clock is 7:11 and 1 second right now. So what that means is that the times of the reservation are based on a time zone or a clock that may not be the same as the one on your computer. So you need to be careful and watch out for that. Now, I'm not sure right now, but I think the systems will normally be in universal coordinated time, and they'll be synchronized within a second or two. So, but universal coordinated time is the time in London. So the East Coast of the United States, I think, is like 6 hours or 5 hours offset from it, depending on the time of year. So you need to be careful about the times. If you miss your time slot, you've lost your opportunity. So let's just make another reservation for a different time slot. We'll say go, and we were able to get that. And note, instead of 1 slot, it says there are no more slots left. That means this is your last time slot. You've used them all. At this point, if we go back and try again, there's only 1 time slot left, and we'll go there, and it'll say, sorry, didn't work. Doesn't tell you why, right? What it does is it says it didn't work. And that's because if somebody else gets your access information, perhaps later on, they may actually get this far and find out there are no slots available. So they won't get information on how to use the facility. So that's how the access mechanism works. And of course, if you type in, other things, change the information you provided, it just doesn't work. Or it might create one of those deceptions. We'll go back again and we'll pick something else, and we'll say, there's what you're supposed to do. So again, we'll just walk through this. Here's why. You get a tiny URL. If it's not a valid one, we have availability improvements because somebody trying to target us by using tiny URLs that they think might be ours but aren't actually ours will get sent to the wrong places. Also, the pointers for the tiny URLs keep changing, so we just assign new ones, one after another over time, and the places you go change over time. So what will happen is if somebody gets an old one, they'll be sent to who knows where. Probably we'll just have a redirect that sends them to the FBI or to the CIA or to Google web search, who knows where. Your unique identifier is used for identity. Now, we don't know who you are. The assignments are given out by your teacher in class. They provide the access information. So we don't have any way to track individuals to who they are, nor are we desirous of that. All we have to know is that you're authorized. If the professor hands out identities to people in their class, the professor can track it, and if necessary, the professor can monitor and deal with issues of your activity. But at the CyberLab, we don't actually have any personally identifiable information at all about our users. And of course, if the unique identifier is not yours, the sequence, who knows what will happen. And so that supports availability and use control in that people will get sent to somewhere that, can't interfere with our processes. And of course, they won't be able to gain access because they won't know where to go to get access. An example of what might be asked for would be a product code instead of just those blank fields. So you have to know, if you're using the facility, that there's some identifying information that'll be obvious when you go use it, and some activity. And it's can always be identifying information followed by activity. So that's a hint. So this anti-targeting is what we're trying to do by putting up deception. So if it asks for a product code, that's so somebody trying to get into the CyberLab says, oh, they're asking for some product code that has nothing to do with the CyberLab. Then the activity code, same thing. It's authentication and identification. That is, it identifies you as being legitimate and authenticates that you're able to do the thing you're supposed to be doing, or that you've been given the information necessary to do so. If it's not valid, if the activity code isn't valid for you, for you and your activity, then it might generate some output, who knows what. And so again, that provides this availability and use control. Asking for an appointment time from the available list. That means you can't just put in your own appointment time. If you try putting something else in that's not on the list, it just won't work. It will lead you to, either it's not available anymore, or it might lead you to an answer that's just not the right answer. So again, you need to put in the right information to get the right answers. And then you pick a slot you can make. This is your reservation. It could fail. An example of how it might fail with a completely legitimate request would be simultaneous reservation attempts, where somebody else picked one of the things that was in the menu before you picked it, and so they got it first. And what it'll tell you is it failed, retry. If it works, you get instructions for access. Those instructions that we provided here, go to this URL. That's an example, but it might be any instructions. It might have graphical depictions of things. It might play an audio to tell you what to do, whatever it does. But it's noteworthy that those instructions for access will typically only work for that slot. So for example, they may provide a user ID and a password that only works during that time slot. So if you do it early, it won't work. If you do it late, it won't work. If somebody steals it and tries it another time, it won't work. So normally at the beginning of a class using the lab facilities, you'll have a way to test for your access. So you'll do it at the beginning just to verify that you know how to use the mechanism, that it works properly, that you can gain access to do the sort of thing you're trying to do. As an example, you might be in an online simulation, for one of 3 4-hour time slots, and you need to test gaining access and using the simulation system. So in that case, you would be given access, for a 15-minute period or something like that, just to make sure you could get in and that you understood what the simulation mechanism did. And everybody might be given access to a common simulation system for a period of time. You might need to run as root at the console in a virtual machine, and then you would get the necessary instructions on doing that, and you do a practice run to make sure you could do it. And then during the actual time slots for the lab, you'd be able to do that reliably because you've already tested it. Another example might be submitting a report for grading. You'll need to test access to the report submission system. Now, we don't currently support anything of that sort, but someday we might. Finally, since we're using deceptions as part of our process of assuring that access is reliable, availability and use control, you need to be able to understand when you made a mistake. The purpose of the deceptions is to deceive. They should be hard to differentiate from reality unless you know what's supposed to happen. And by design, the deeper you get into our systems, the harder it is to detect the deceptions we don't want detected. So at the tiny URL level, most bad guesses or other URLs lead to something obviously not the Webster CyberLab. They don't have places to enter data. Who knows what they'll But after the proper tiny URL redirection, tiny URL again, just being what we're using in the example, deceptions are pretty obvious if you know about your class and activity, right? So if there's a strategic game and you get an FTP site to store files as the only instructions, it just doesn't look right. That's what JDLR stands for. Just don't look right. In the labs, there might be additional deceptions. They're intended to support the activity of the lab. Our best advice is to learn to carefully follow directions. So that's the end of the presentation. We'll now have a discussion.